In this video, I am going to discuss some special rules for IUPAC nomenclature and what are the special rules, how to use those special rules, and how to give the correct IUPAC name by applying these special rules. That is what we are going to discuss in this lecture. So these special rules particularly come into the picture when more than two identical chain terminating functional groups are present. More than two identical chain terminating functional groups. First you check whether you are familiar with the chain terminating functional group or not. Chain terminating functional group means the functional group which always exists at a terminal position. For example, aldehyde, carboxylic acid COOH, ester functional group COOR, amide functional group C double bond O NH2. So these are all chain terminating functional groups. That means in this functional group, if you carefully observe, three valencies of carbon are fixed. You can see two valencies are with oxygen and one valency is with NH2. Whenever three valencies are fixed, it has only one free valency, therefore it cannot be at the middle of the carbon chain, always it will be at a terminal place. Even here also you can see in aldehyde functional group, carbon 3 valencies are fixed. Here also carbon 3 valencies are fixed. Even in case of this 3 valence fixed, we also have acid halide, cyanide, some other examples also. So these functional groups are said to be chain terminating functional group. So whenever more than two identical chain terminating functional groups are present, we have to use these special rules. And these special rules under this situation, we are, for the sake of convenience, we are classifying them into two sub rules. The first one, if all chain terminating functional group, if they are directly attached to principal carbon chain, more than two identical chain terminating functional groups are present and all of them are directly attached to principal carbon chain. What does it mean? So you can see these are the aldehyde functional groups chain terminating. This is the principal carbon chain. So 1, 2, 3, all of them are directly attached. Chain terminating functional groups, we have three. So all three are directly attached to principal carbon chain. Even you can observe this situation, even this situation. In fact, so here this is the principal carbon chain. So here this is the principal carbon chain and all of them are directly attached to the principal carbon chain. In all these situations, we have to use some special rule to give the correct IUPAC name. And what exactly we have to do? No carbon of a functional group is taken into the longest chain. All are important. This is important, this is important, and this is important. This is directly attached to the principal carbon chain. So we can take in the longest chain this one and this one we can take, but simultaneously this carbon cannot be taken into the longest chain. We cannot name this particular group as a prefix because all are equally important. But it is not possible to select the chain with the carbons of all three aldehydes. In that situation, we should not select the carbon of functional group into the longest chain. We have to select the longest chain without taking carbon of those functional groups. And we need to give the special suffix in case of aldehyde, carbaldehyde, in case of amide, carboxamide, in case of nitrile, carbonitrile, carboxylic acid, like that. No carbon of functional group is taken into the longest chain and we have to use the special suffix. Instead of explaining the rule again and again, let me apply the rule so that you will understand. So here now this is the longest chain. You can give numbering either from left side or right side, the result will be same. Now the root word is prop, ane, 1, 2, 3, tri carbaldehyde, carbaldehyde. So we have given equal preference to all three carbons of aldehydes. So again, you can see this is the principal carbon chain. Three chain terminating functional groups are directly attached to the principal carbon chain. So we are not taking these carbons into the longest chain. We need to use the special suffix. So here this is again propane 1 comma 2 comma 3 tricarboxamide, tricarboxamide, like this. Same situation here also you can see. So here 3 carbon chain 1 2 3. So root word is again prop, primary suffix 1 comma 2 comma 3 tri carbonitrile. You understand it properly. Again you can see 3 carboxylic acids, all of them are directly attached to the principal carbon chain. This will be propane, propane 1 comma 2 comma 3 tricarboxylic acid, tricarboxylic acid. And here you can see again there are 3 COOH groups, all of them are directly attached to the principal carbon chain. So here this is the principal carbon chain, and the numbering should be from right side, because if you give numbering from right side it will be 1, it will be 2 and it will be 4, 1 to 4. If you give numbering from left side it will be 1 3 4, 1 2 4 is better, therefore like this. So this is a 4 carbon chain butane 1 comma 2 comma 4 tricarboxylic acid, tricarboxylic acid. Now first let us identify the principal carbon chain. This is the principal carbon chain, and here special suffixes, these are not prefixes, be very clear, but this is a prefix, this is a prefix. Numbering must be from right side, because here this is 1, this is 2 and this is 3 4 5 6 and 7. In that situation we are getting here aldehyde at first place, aldehyde at third place. If you start numbering from this side, okay, one aldehyde is at first place, but this will be more than 3. You just check the possibility by giving from left side, and it's very clear this is a substituent methyl group. In order to indicate the name of substituent we have to use a prefix. Ultimately the name of this compound, that is 6 methyl, after that root word hept, primary suffix ane, 3 aldehydes, special suffixes we have to use 1 comma 3 comma 7, 1 comma 3 comma 7 tricarbaldehyde, tricarbaldehyde. So here this is the first rule. More than 2 identical chain terminating functional groups, all of them are directly attached to the principal carbon chain. This is the rule and these are the examples. Now again we have more than 2 identical chain terminating functional groups, but all identical functional groups are not directly attached to the principal carbon chain, not directly attached to the principal carbon chain. For example, here one, it's not numbering, just a longest chain. This is the longest chain, like this. If you carefully observe, 1 2 3 4 5, like this. So you may have a doubt like, why are you moving like this in this direction? I'll clarify. 1 2 3 4 5 6 7 carbon chain, 1 2 3 4 5 6 carbon chain, obviously 7 carbon chain. But if you carefully observe this particular aldehyde group and this particular aldehyde group, these two aldehyde groups are not directly attached to the principal chain. So they are separated by some carbons like CH2 and CH2. This is directly attached to the carbon chain. This is attached to the carbon chain. In fact, this one also. but this is not directly attached, this is also not directly attached, because one CH2 group is separating, two CH2 groups are separating. In that situation, the aldehyde groups here are chain terminating functional groups which are not directly attached. They should be named as prefixes. Their names should be indicated as prefixes. Substituent name we have to give. And be clear here, numbering should be from right side. You just check why only from right side. You just pause the video. What will happen if I give numbering from left side and right side also you give, then you compare whether you can apply least locant rule properly or not. Check yourself. I don't want to waste the time. So this is the first carbon, this is second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon and seventh carbon. So here these are directly attached, therefore these names will be suffixes. But this will be prefix, this will be prefix. If you carefully observe, this is one carbon, this is one carbon, this is oxoethyl, and this is oxo 1, 2, 3 propyl, oxoethyl, oxopropyl, oxoethyl E, propyl P, E comes first. Therefore, at a third place, we have 3, and this is point of attachment here, first carbon, second carbon, 2-oxoethyl, and this one at a fourth place, 4. To avoid confusion, you see this is a point of attachment, the first carbon, second carbon, third carbon, right? So that is actually this is at located at fourth place. So that is 4, 3-oxopropyl. Both the prefixes are completed. Root word hept, all CC single bonds, all are CC single bonds, heptane 1, 2, 7 tri carbaldehyde. First understand the rules, then apply the rules. Without understanding the rules, if you learn the subject from the questions, there will be no longevity. So this is the correct IUPAC name of the compound. Let us take one more example. We have aldehyde group, again one more aldehyde, two groups here. This can be taken into the longest chain. Therefore, numbering should be from this side, 1, 2, 3, 4, 5, 6. So what I am trying to convey is, this is directly attached, this is directly attached, this is not directly attached. Therefore, this is however receiving prefix treatment. Now we can select these two. If you have one more aldehyde group, then this one will be ignored. Special suffixes you should use. But these two carbons can be taken into the longest chain, and the name will be, so that is 3. It is a complex substituent. So this is the first carbon, second carbon, 2-oxoethyl hexane 1, 6 diol. Prefix name. Here also there are chances for committing mistakes. Some students will say formyl methyl. That is wrong. Formyl methyl is wrong. So this is first carbon, second carbon, 2-oxoethyl hexane 1, 6. Don't use the special suffix here because this is already taken into the longest chain. And the last rule is numerical prefixes bis, tris are used to indicate the number of complex substituents. If complex substituents are repeated, instead of saying di, tri, you have to use bis for the repetition of 2, tris for the repetition of 3, tetrakis for the repetition of 4. So these are the special rules with examples. Thank you very much.